During the adapt stage, many updates were made to gain efficiencies within the system.
First, we refined the wave energy converter components to capture a larger fraction of wave energy across all expected wave states. To do this, we added a large radius primary gear on the spring wheels and a small radius gear on the freewheel mechanism attached to the generator.
This increases the generator RPM for a given wave velocity and boosts the average power output of the WEC.
We also integrated a high-efficiency DC-DC buck converter to increase the DC voltage to the pier during testing, which will lower the required current and make it much easier to use low-current, low-mass wiring to the pier.
A DC motor and worm gear was also installed and programmed, which drives the linear PTO motion on the rails to account for tidal variation. Throughout the system, we've worked to standardize components and hardware as much as possible, making assembly and any future adjustments super efficient.
We're really excited to deploy the full-scale system and start generating desalinated water for the first time.
We've learned so much from testing smaller prototypes and subsystems, and this will be the first opportunity to see it all in action.
From a physics perspective, it's always fascinating to see how well our mathematical modeling holds up in the real world. Our adapt stage winnings have provided us with a longer test deployment effort, allowing us to gain real-world data on how well the system is working and targeting areas for improvement.
It's also allowed us to invest in digital tooling and machining equipment that's been immensely important in our prototyping efforts.